Hey guys, I'm Josue Hernandez, and today I will explain arithmetic series and geometric series. The objective of both arithmetic and geometric series is to find the sum of all the terms in that series up until a certain term. An arithmetic series finds the sum of all terms when you're using an arithmetic sequence. In an arithmetic sequence, all the numbers have a common difference which never changes. For example, in the arithmetic sequence 21, 23, 25, and 27, the common difference is 2, which is then added on to each term. The common difference is usually either added or subtracted to each term. You can use an arithmetic series whenever you have an arithmetic sequence that has an end. Arithmetic series can be solved using one of two equations. Sn equals n over 2 times u1 plus un, or alternatively, you can use Sn equals n over 2 times 2u1 plus n minus 1 times d. In the series, u1 is the first term in the series, d is the common difference between each of the terms in the series, and un is the last term that you'll add in the series. N is the number of terms we are using. Here they give us an arithmetic series of 3 plus 7 plus 11 plus 15, and they want us to find the sum up to the first 20 terms. We can find the common difference by subtracting 15 by 11, 11 by 7, and 7 by 3. All of these will give us 4, so the common difference is 4. Since they want the total all the way up to the first 20 terms, then we have all the things we'll need to actually start working. N will be 20, U1 will be 3, and D will be 4. Then we plug everything into the equation and solve for Sn. Now, in this problem, they'll give us an equation that will give us Sn, but now we have to figure out terms using this equation. To solve for the first and the second terms, we need to put n at 1 so that we can find out the first term, and n at 2 so we can find out the sum of the first and the second term. Then we'll subtract the first term from that. This next segment is similar, except now that instead of n equals 1 and n equals 2, it'll be n equals 19 and n equals 20. On the other hand, we have geometric series, which are used to find the sum of all the terms in a geometric sequence instead. Unlike arithmetic series, geometric series uses a common ratio instead of a common difference. This common ratio is multiplied to the previous term in the series to find the next term in the series. For example, in the geometric sequence 1, 2, 4, 8, and 16, the common ratio is 2, because each of the previous terms is being multiplied by 2 to find the next term. Like arithmetic series, geometric series has two different formulas that you can use to solve for the sum. You can use Sn equals u1 over r to the power of n minus 1 over r minus 1, or alternatively you can use Sn equals u1 times 1 minus r to the power of n over 1 minus r. In a geometric series, u1 is the first term in the series, r is the common ratio, and n is the number of terms in the series. Here we have a geometric series of 12, 6, 3, and 1.5, and they're asking for the sum of this all the way up to the first 10 terms. Before we begin using the actual formula, we need to find out what our common ratio is. To find that out, we divide 1.5 by 3, divide 3 by 6, and divide 6 by 12. All of these should give us 0.5, so the common ratio is 0.5. Knowing that they want the sum up to the first 10 terms, we can start working. N will equal 10, U1 will equal 12 because that's the first term, and R, the common ratio, is 0.5. Once we plug all the variables in, we'll end up with an equation that is 12 times 1 minus 0.5 to the power of 10 over 1 minus 0.5. Once we solve this equation, we'll end up with 23.97, which would round up to 24.